Okay, continuing on with Chapter 8. This is Section 8.5, Factoring a General Strategy. And what we're doing is we're just going to do everything we've looked at up to this point, and we're going to use it to be able to factor these equations or these expressions. And so sometimes we'll have to use trial and error. Sometimes we'll have to use special, products, all kinds of different things. And so we just kind of have to remember everything we've done up to this point. So what do we have here? Well, this looks like not much of anything. And so what we're going to have to do is we're going to have to do trial and error, I think. And so how do we factor 5u? Well, that's going to be 5u and u. That's the only way we can do it because it's going to be 5, it's going to be 1 and 5, and so that's going to be this. Now here we have a plus, but here we have a minus, so I know it's going to be minus and minus. And now I can do 4. Well, 4 is going to be 1 and 4 or 2 and 2. Okay, well, I usually say do 2 and 2. So if we plug in a 2 and a 2 here, it doesn't matter which one is where. 5u times that's going to give us a minus 10. And here's going to be a minus 2, so that's going to be minus 12. So that doesn't work. So 2 and 2 doesn't work. So let's try 1 and 4. So here we have 5 times a minus 4 is a minus 20. And then here we have a minus 1, that's minus 21. So that doesn't work. So now let's try the other way for 4 and 1. So here we have 5 times a minus 1 is minus 5. Here we have a minus 4 times that's minus 4. And so that's going to give us a minus 9. So that looks to be what we need. So we need that, and then we need a 1v here. So now let's test it. 5u squared. Then we have a minus 9 or minus 5uv minus 4uv, so that's going to be a minus 9uv plus 4v squared, and so then that is our actual factored form. And again, we had to go through 3 ways to get to it, but that was trial and error, and that's how it works. You could also do the factor by grouping and do that, but I find trial and error to be a lot quicker and easier for myself. All right, so on this one, what are we going to do? Well, it looks like we have n we can pull out of, and that gives us 5n squared plus 7n minus 6. So that's going to be the first thing I try. Now I have to decide, can I factor this? Well, that's going to be, it's going to be a 5n and an n. Here we have a minus, and here we have a plus. So the larger one has to be plus. And so we have to think about the factors of 6 now. So 6 are 1 and 6 and 2 and 3. And again, I'm going to try 2 and 3 to start with. And so now I'm just going to have to play with the numbers being plus and minus on each side. So if I take 5 times 3, that's 15. And then I subtract off 2n, that's going to be 13. So that doesn't work. So no. Well, what about 3 and 2? And so here I have 5 times 2 is 10, minus 3 times n, which is 3. So 5 minus 3 is 7. Aha, that's what I need. And so I said the larger one had to be positive. So the larger one has to be here. The smaller one has to be here. That's just the negative 3n. So 10n minus 3n is going to be 7n minus 6. And we have still our n out front that we factored out. And so we are done with that factorization. Here we only had to try 2 before we got to it. And sometimes, you might have to go all the way to that first one, the 1 and 6. But this one worked out nicely. We only had to do the 2 different versions. All right, so looking at that one, I see the x squared and a minus a y squared. So that looks to me like a difference of squares. Well, what is 9? Well, 9 is 3 squared. What is 25? Well, that's 5 squared. So this makes it easy. So now I just have a 3x plus 5y and a 3x minus 5y by using the formula for the difference of squares. Now to test it, 3x times 3x is 9x squared, check. Then we have 3x times a minus 5y, it's a minus 15xy. Then here we have plus 15xy, so those are gone. Then we have a 5y times a minus 5y, so it's going to be a minus 25y squared. And so then that would be my factored form. Again, knowing that this is a difference of squares, knowing how the difference of squares works, makes this really a quick and easy way to do it. Now, if I didn't have that, what I would have to do is think about factors of 9. Well, that's 3x and 3x, and 25 or 5 and 5, because I would go ahead and, I could do 1 and 9 or 3 and 3, and then 25, I could do 1 and 25 or 5 and 5. Remember, I always do the middle ones first. And I would have got to that point, and then I would have had to know that, okay, one's going to be plus, one's going to be minus. Because if I had two minuses, it'd be plus. If I had two pluses, it would be plus, and I need the minus. So I know it has to have opposite signs, and that would automatically get me where I need to go as well. All right, what about this one? Well, this one has 4 terms, so that means I'm going to have to factor by grouping. So now what I want to do is this in an order where I can just, put parentheses around the first 2 and the last 2 and be done? Well, if I do that, I don't have a lot of common terms. But if I look here, I have a b squared here and a b squared here. And so I'm going to put those 2 terms together. And then this one has an x, this one has an x. So I'm going to put those 2 terms together. So now I'm going to write this as 36b squared c. Then I'm going to say minus 24b squared d. I'm going to group those together. Then plus. Now, I notice that here I have larger than smaller, and here I have larger and smaller. So I'm going to write the 24 first. 24xc minus 16xd. And now I'm going to start pulling out terms that are common to both of those. So if I look at that, what do I have? What do I have here? So I have a b squared I can pull out for sure. Now here, it looks like I have 12 I can pull out. It looks like there's a 12 in both of those. Anything else that has common? It doesn't look like it. So if I pull out a 12, that's left with a 3. And after a b squared is taken out, I have a c. If I take out a 12 out of here, I have a 2. And what's left is a b. So that's my first term factored out, the GCF. What's my GCF of this one? Well, it looks like I have an 8 in both of those, and I have an x in both of those. If I pull out an 8, I have 3c left over. If I pull out an 8, I have a minus 2d left over. And do I have the wrong term written somewhere? I do. This is supposed to be a d, not bb. And so I was like, okay, so that's a d, not a b. And now I notice 3c minus 2d, 3c minus 2d. I can pull that out front. And then I have 12x left over. All right. And now I look and say, I have common term to both of those. So you know what I should do? I should probably look up here and say, hey, I have a common factor in all these. I should probably pull that out first. But I see it here, so as long as I saw it here, I'm okay. So I have a 4 I can pull out. And if I pull that out, I have a 3b squared plus 2x. And then I have my 3c minus 2d. And now I've got this factored completely because I don't have any common terms here. I don't have any common terms here. And so that's as far as I can go as this factorization. And I am done. And again, I should have recognized at this point all of those have a 4 in common and pulled it out first, but I didn't. But I did notice it at this point here. I saw that there was a 4 there, and so that would be my factored form. All right, what about this one? Well, this time I remember, hey, let's look for GCFs first. So I see that I have a 2 in all of them, and I also have an x in all of them. So if I pull out that 2x, what do I have left over? Well, I have x squared, then I have a 3xy, and there's my plus, forgot to put that in, minus, I pull out a 2 out of there, I have 10, and then I have y squared, okay? Well, now what can I do? Well, I can factor that, I hope. So let's try. So it's going to be x and x. And one's going to be plus, one's going to be minus because I have a minus here and a plus here. And the larger one's going to be a positive. So 2 factors of 10 that when you subtract them get 3, well, that's going to be 5 and 2. And so the larger has to be here, so that's going to be a 5y. And that's going to be a 2y. So now let's test it. X squared minus 2xy plus 5xy, so it's going to be 5 minus 2 is 3xy. and then minus 10y squared, and then times 2x. That puts me back up to my original expression when I multiply it out here. So that is my factored form at this point. All right, now this one, I have an x cubed, so that automatically keys me in on I'm probably doing the difference of cubes. So what is 27? Well, that's 3 cubed x cubed minus, well, what is 64? That's going to be 4 cubed, and so we have 4 cubed. And now we know that there's a formula we can do, and it's going to be a minus b, so it's going to be 3x minus 4, because the first one's going to match. And then we're going to square the first term, so it's going to be 9x squared plus, because those have to be opposite, then 4 times that, that's going to be 12x. Then plus again, because my last term's always positive, and 4 squared is 16. And so this will be my factored form. And so then I had to know the difference of cubes formula to be able to get to this point here. So that's, again, another important formula that you need to know, and that's the only way you can actually factor that is if you have that formula. All right, what do I see here? Well, I see that 3 looks to be in each of them, and k looks to be in each of them. So if I pull out a 3k, what do I have? I have a k squared minus 9k, and then plus, and then that's going to be a 20. All right, well, what can I do with that? Well, 3k times, well, it's going to be k, and now that's going to be minus and minus. And 2 factors of 20 that add to 9, well, 5 and 4. That works, I think, 5 and 4. So k squared, then we have minus 4k, minus 5k is minus 9k, then plus 20. And then if we multiply that by 3k, we get back to 3k cubed minus 27k squared plus 60k. And so then that would be my factored form. Again, that's one of the easy ones. You pull out the GCF, and then it's pretty easy after that, figuring out 2 factors of 20 that add to the 9, because we have to have both of them be the same sign. All right, what about here? When I see something like this, I'm thinking probably the perfect square trinomial. And so what I'm going to think about is, well, let's try it first long factoring, and then we'll do and see if that equals what the perfect square trinomial is. And so 16x squared, well, I'm going to try 4x and 4x because that helps me with the perfect square. And y squared is going to be y and y. Now to get the negative here and the positive here, I have to have negative and negative. Now let's check it. That's 16x squared, and we have minus 4xy, so it's minus 8xy plus y squared. And so we could say that's what it is, or it's just 4x minus y, the quantity squared. And that would be what we had if we had the perfect square trinomial directly, or if we did it by longhand and doing the trial and error method. All right, here again, it looks like we have 4 terms. And so what I'm going to do is I'm going to decide, well, do they line up as they are? Can I just pull it out as they are, or do I have to rearrange them? Well, I noticed that we have an x here and an x here. We have a u here and a u here. We have a 20 and a 20 we could pull out, and a 5 and a 5 we can pull out. So I'm thinking as they are is how I'm going to try to do the factorization. And so I'm going to have 20uv minus 60u cubed plus, then I'll have a minus, and that's going to be 5xv plus 15xu squared. Okay, and so now I have it into the group form. Now I have to look inside each one of these and see what kind of GCF I can pull out. So here I see I can pull out a 20, and I can pull out a u. If I do that, 20u, that leaves me with a v minus 3u squared. Okay. Well, here, if I pull out an x and a 5, well, I better pull out a negative 5. If I pull out a negative 5x, that leaves me with a v. Now, that kind of matches what that is, so that's kind of why I decided to pull out the negative here. And if I take out a negative here, that's going to give me a minus. And if I take out a 5, that's a 3. Take out the x as u squared left. So now I've got this as my GCF, so I can pull that out. And what's left is 20u minus 5x. And so this is almost my factored form because I just realized that I did it again. I had a 5 I could pull out of everything, and so I have a 5 I can still pull out of here. So that's going to be a v, I don't know what that is, minus 3u squared times, now if I pull out a 5, that's going to be a 4u minus x. Now that's going to be my total factored form. And again, you really have to pay attention when you get to this point, especially with the ones that are grouping like this. Sometimes you factor by grouping, and then all of a sudden you're like, oh, hey, I have that common term of 5 in that binomial, so I have to pull it out in front, and then that gives me my final factored form of that four-term polynomial. All right, so as I did last time, I notice now I have a factor of 5 here that I can pull out. All right, so if I pull out the 5, what do I get? Well, I have a 9u squared, and then that's going to be minus 30uv, and then plus 25v squared. Okay. Now I see that those are perfect squares, and so this is probably a perfect square trinomial. And because I have a negative here, I'm going to say, okay, well, if this is a perfect square trinomial, that's going to be 3u, then minus 5v squared. So that's what I'm guessing my answer is, assuming that this multiplies out. But what I'm going to do now is I'm going to do it long way to make sure that that's really the case. And so then I can actually do the FOIL back out to see if that's what I get. So if I say that's 3u minus 5v and 3u minus 5v, if I multiply that, that's 9u squared. Then I have a minus 15uv, minus 15uv, so that's a minus 30uv, and then plus 25v squared. And so that is my correct answer. And so basically, I just wanted to make sure that when we get down here, and we multiplied it back out, we get the right answer, and that is the correct answer. All right, those cube terms here, those key me in on that this is going to be the sum of cubes. And so what are the sums? Well, that's going to be a 4 cubed m cubed plus 3 cubed n cubed, because 3 cubed is 27, 4 cubed is 64. And so I have to use my formula. So the first one is going to be plus between them because I have a plus here. So that's going to be 4m and 3n. And then I square the first one, so that's going to be 16m squared. Now I have opposite sign. Then I have to multiply those together. 4 times 3 is 12mn. And then I have plus, I square the last term, that's going to be 9n squared. And so that then, crookedly line, is going to be my factored form. Again, I need to know the formula for the sum of cubes to be able to get this to work. There's no other way to factor it without knowing that formula for the sum of cubes. Well, now look at that. We have cubes again, but this time we have the difference. And so what do we have here? Well, that's 4 cubed m cubed minus n cubed. So we're going to say, well, that's 4m. Now we have a minus here, so we have to have a minus here, n. Then we'll square that first term, so that's going to be 16m squared. Now we have to have the opposite sign, so plus 4m times n is 4mn. Then plus the n squared. And again, we had to know what the formula was for the difference of squares. And again, it's the same as with the sum of squares, except this and this have different signs. If it was a sum of cubes, that would be a plus and a minus. Because it's a difference, it's a minus and a plus. All right, here I see there's a factor of 2 I can pull out. So that gives me x squared minus 5x plus 6. Now I have to find the factors of 6, both of them the same sign, in this case negative, that add to 5, well, that's going to be x minus 2, x minus 3, because here that's going to give me plus 6. Here we have minus 3x minus 2x is minus 5x, and then that's my factored form. So that was one of those, it falls into place really easy, and we only had to find the two factors of 6 that add to 5, which is 2 and 3. There's only another one, which is 1 and 6, but when you add those two together, you get 7, and so that one we could throw out, and so only 2 and 3 add to the 5 and multiply to get 6. Okay. All right, here, what do we have? Well, this one, I see I have common factor again. What is that common factor? Well, it's x squared. If I pull out x squared, I have x. If I pull out an x squared here, I have plus 4. Now, at this point, there's nothing I can do here. X squared in this form, we could leave it as that because, sometimes we had x plus 3 squared. That was our factored form, and that's similar to what x squared is, except, we had x plus 3. Now we have just x. And so this then is all we can do. We can just take out that GCF, and we're done. If we multiplied it back out, x cubed plus 4x squared, and we're done. All right, what about this one? Well, if I look there, I see there's a v squared in all those terms. So I can factor out a v squared. If I do that, I have a 2u squared minus 11uv plus 15v squared. Okay. Now, looks like I'm just going to have to factor by trial and error. And so I'm going to say, well, that's a 2u and a u, and it's going to be a minus and a minus. And now my factors of 15 are 1 and 15 and 3 and 5. I'm going to try the 3 and 5 first. So I'll put a 3 and a 5. Again, I don't know which way it goes, so we'll just try this way first. And we have to add together to get the 11. So 2 times 5 is 10, plus 3 is 13, so that does not work. What about 5 and 3? So 2 times 3 is 6, plus 5 times u is 5, so 6 plus 5 is 11. So that looks to be, oops, it's supposed to be a 3. That looks to be our factorization. And again, we have v squared, so we have to have a v and a v. So multiplying that out, that's 2u squared. Then we have minus 6uv minus 5uv, so that's minus 11uv. And then we have plus 15v squared. And so that one is as far as we can factor it. And again, I just did trial and error. I just did those two. And the first one did not work. The second one did. And then I just plugged them in, and that was my answer. And that's all I have for this section.